Hello everyone, welcome to my channel. So today we shall discuss the chapter Matter in Our Surroundings, that is in your class 9 chapter 1. So at first let's learn what is matter. So matter is anything that have mass and occupies volume. Like example, whatever we can see around us, like the table, chair, pen, book, anything that have mass and occupies volume is called matter. Now this matter are made up of particles. How we can detect that? So there are two processes that explains that matter is made up of particles. One is diffusion, another is Brownian motion. So now what is this diffusion? As you can see in a beaker, pink or violet color substance is getting diffused. Diffusion has come from the word diffused. Diffused means getting into one substance is getting into another substance. So in this beaker, this colorless solution or this colorless substance is the water, and this purple or violet color substance that you can see, these are potassium permanganate crystals. These potassium permanganate crystals, when we add to this colorless water, what happens? We all know that they will slowly go down into that water and they will discharge its color into that water, and the time will come when the entire water will turn purple or pink. So this is the process of diffusion, means to get diffused into another substance. Similarly, this Brownian motion. This Brownian motion was given by the scientist Robert Brown. With his surname, this Brownian motion have been discovered, or Brownian motion have come. So in this, Robert Brown, what he did, he has taken some pollen grains and he added into a beaker of water. Now by microscopic vision, what he saw, that suppose this blue color particles are water molecules and this red color big particle is the pollen grain. Now what he have seen under microscope, that this red color, this red color particle was constantly moving. This red color particle was constantly moving. So he concluded that every particles in a matter are constantly moving. So the liquid or the water particles were constantly moving in a zigzag path. They were constantly moving in a zigzag path. That's why, due to the, as you can see the arrows, this arrow says that water molecules were moving in a zigzag path. So when one water molecule collide with this pollen grain, it displaces from its position to another part. Then another water molecule comes and hits that pollen grain. So similarly, this pollen grain was found to move in a zigzag path. This pollen grain was found to move in the entire water under microscopic vision, that it was moving in a zigzag path. So he concluded that water molecules were moving in a zigzag path, that matter is made up of particles. So these are the two processes that explains that matter is made up of particles. As you can see, one incense stick, that is agarbatti, that we know. So here also diffusion occurs. How? This smoke from this agarbatti gets diffused into our atmospheric air. That's why in an entire room, when we lit this agarbatti, we can see that the entire room spreads with that fragrance. So this is one conclusion, that matter is made up of particles, and the explanation is given by the process diffusion. Now let's move to the next page. So the conclusion of diffusion and Brownian motion is matter is made up of tiny particles, and particles of matter are constantly moving. By Brownian motion, we have come to know that particles of matter are constantly moving, like in the this zigzag pattern of water, or zigzag pattern of that pollen grain due to water movement of the water molecules, and matter are made up of tiny particles. Particles of matter are very small. Now how we will know that particles of matter are very small? So this is an experiment that had been conducted. So here we can see deep purple color solution. This is due to the potassium permanganate solution. We have taken few crystals of potassium permanganate and we have dissolved it in 100 ml of water. We have dissolved it in 100 ml of water. Now what happens? As you can see, this picture is more clear to you. This is a very deep colored solution. Suppose this is 100 ml solution of potassium permanganate. Now what we will do, we will gradually do a process. We will take 10 ml of this deep color potassium permanganate solution and we will take into another empty beaker and we will add 90 ml of water. So what we are doing? At first we are making in a beaker 100 ml concentrated deep color potassium permanganate solution. Now from that we will take 10 ml potassium permanganate solution and we will add it to an empty beaker. And with that 90 ml of water we will add. So in that beaker also 100 ml solution will be there. Now similarly from this beaker, this second beaker, we will again take 10 ml of the solution into this third beaker and gradually we will add 90 ml of water into this third beaker. So like this we will continue the process. We will see, just a minute. Okay, so we will see that the color of this potassium permanganate on dilution decreases. Means we will see in this container or in this beaker the color was very bright, and in this last container we will see the color is very faint. So it explains that particles of matter are very small because the more we dilute, but still we can see the faint color of that potassium permanganate. So there are very small particles that matter are made up of. That's why on dilution, on huge dilution also we can see the color. Though the color is not that much bright because the number of particles of that potassium permanganate on each dilution decreases. So this is the reason, as you can see here, that the more we add water, the color gets faint, but this faint color also contains the potassium permanganate particles. So this explains that particles of matter are very small. Particles of matter have space between them. So to explain this, an experiment have been conducted. This is very familiar experiment, or this is very familiar process that we do at regular basis in our homes. That is adding salt into water. So here we will learn one term called intermolecular space. So as you can see in the diagram that this is 50 gram of sugar, and this 50 gram of sugar I will add into 100 ml of water. So as you can see, this is the water mark, or this is the level of water. Okay, so after adding this sugar, we will gradually stir it. Okay, by a glass rod or by any spoon, we will stir it. After it makes the solution, that is the sugar solution, we will see that the level of water will not rise. The level of water will not rise. This gives us one result that water molecules have huge space between them. That is precisely to say intermolecular or interparticular space. That is, the particles of water have huge space between them, or the water molecules have huge space between them that can accommodate this sugar into it. That's why the volume of the water do not rise. Particles of matter are constantly moving. So in the first page of the chapter, we have seen that the lighting of agarbatti. Similarly here, when we lit an agarbatti, what happens? This we can see the smoke is constantly moving in an entire room. If we lit a agarbatti, we can see the smoke is constantly moving. That's why a person who is standing at the corner of the room can smell the fragrance of the agarbatti if it is far away from him. This is the reason that particles of matter are constantly moving, so that due to this we can smell the fragrance of the agarbatti. So these gas molecules or the gas particles or the smoke particles of this agarbatti move from its original place to the entire room. So this was it. Thanks for watching. The next part I will share soon.